Welcome everyone to the AI Research Bites. This series of short and informative talks showcase cutting-edge research work from ServiceNow AI Research team. These sessions are open to all, especially those interested in keeping up with the fast-paced AI research community. And you know what? Also multimodality, like we're going to learn about today. Today's session, as I already spoiled it, is about multimodality, but for time series and natural language. So Andrew will present their new approach, their new technique to tackle this huge challenge. And as usual, it will be followed by a 10-minute Q&A. As usual, please use the Q&A button at the bottom of your screen so it's easier to manage, questions. Andrew Williams is a PhD student at the CERC lab under Inverness. Sorry, I completely butchered the name.
No, it was good. It works.
And Université de Montréal. He's currently a visiting researcher with us at ServiceNow Research, and he's mainly focusing on GenAI for time series forecasting, which is the topic of today. Also interested in multi-agent systems and AI to support research and discovery. Up to you, Andrew.
Awesome. Thank you so much, Fanny. And thank you very much for organizing these talks. I know they're great, and for the support. There's a lot of work behind the scenes that goes into making these talks possible. So thank you so much for that. And thank you to you, the audience, for being here, for making time today. Today, I'll be talking to you about our new paper, our ongoing project and new paper, which is called Context is Key, a benchmark for forecasting with essential textual information. This is a first co-authorship with Arjun Ashok that you can see up here. And then there's this full list of authors: Etienne Marcotte, Valentina Zantedeschi, Jitendra Subramanian, Roland Riachi, James Rakema, Alexandre Lacoste, Irina Risch, Nicolas Chaparos, and last but not least, Alexandre Drouin. So, those are all the authors, many of them at ServiceNow. So let's get started. Before we get started, here's a safe harbor notice. I don't know what I don't know. This presentation is to the best of my and my team's knowledge. So yeah, let's get going. Okay, so this is what the agenda is going to look like for today. First, we're going to go over what forecasting is and why context matters for decision making, despite existing methods mostly not using context. Then we'll introduce the main topic of this talk, which is the benchmark for what we're calling context-aided forecasting. And then finally, we'll go over how existing methods and models do on this benchmark and what future work on this important problem setting could look like. Okay, so first, forecasting. What is it and why it matters? Forecasting basically is leveraging statistical methods, judgment, or both of those to predict the evolution of key indicators, which helps provide insights into critical business functions. That's basically it. We're trying to forecast the evolution of variables or things that we care about to help us derive insights. And so let's jump right into an example. Right? Typically, we use statistical methods for this. And so what it looks like is you have this black line over here. Let me pull out the highlighter for this. You have this black line. And then what you're trying to do is based on this this history of something, I ask you to tell me what's going to happen next, kind of like predicting the next word of a sentence. And this is typically how forecasting models work. I show them the black line, and they generate predictions of how it would extend in the future. And, in many cases, existing statistical methods work well, but, a good forecasting model might give you something like what we see the blue line is here. But if we look at what actually happened in this case, this yellow line, we see that the blue line is pretty far off. And the point here is that even if the statistical model is good, its prediction is actually far off from the truth. And that's because this black line here just is not informative enough to predict the yellow line from it. Right? Now, suppose you're a decision maker and you're given this forecast, this blue line. If your model gives you this prediction, you might end up basing important decisions on it, and that might have important repercussions. Or if you know that the forecast is not appropriate, well, you might adjust the forecast if it's a simple adjustment to do, or you might just throw it away otherwise, right? And so the point here is that, even good forecasts might be lacking information, right? But now let's suppose that we consider the same problem, so same black line, but I give you the following context. In other words, I give you this key non-numerical information that goes along with the problem, right? I tell you that this series contains the power production of a photovoltaic power plant in the state of Alabama. And I tell you that over the previous 90 days, the maximum power production happened around 1120. Okay. This is a lot of important information for the problem. It's actually really helpful. It tells you that your series is already close to its maximum, and it might even give you insight into what the forecast should look like. And if you use this extra context, well, you can actually make much better predictions than without the context. And so what we want to be able to do is to combine numerical data and contextual information to make informed data-driven decisions, right? And this prediction that we see here in blue that aligns much better with the yellow line than the previous prediction we saw is actually made by an off-the-shelf prompted language model, but we'll get to that later. The basic point of this being that we think this problem setting can really be useful for a broad range of users, especially those that might not have the time or resources to do fancy forecasting methods, but want to make data-driven better decisions, right? That being said, there's a hiccup in this, which is that standard methods ignore context. They just don't use context in their forecasts. But if humans use context to make better decisions and better predictions, I mean, why can't AI do this too? Like, we definitely saw that it helped our model in its previous prediction. And we know that at top forecasting companies, humans are definitely involved in the forecasting loop, and they will amend their forecasts with their technical know-how. But if you don't have that technical know-how or the resources, then you're kind of forced to choose between making data-driven decisions or context-aware decisions. And that's not a choice that we want to make. So before we move on, here's a few examples of, relevant context in enterprise settings, all right? So for example, in customer service management, we might worry about staffing forecasts or, incident volume forecasts, things like that. And relevant context here can be holidays, product launches, outages, things like that. In terms of performance analytics, where we want to predict KPIs or service bottlenecks, maybe we care about special events or changes in the workforce distribution can be very relevant. And in the longer term, for strategic portfolio management, well, for things like scenario planning and strategic planning, market trends, changes in roadmaps, things like that can absolutely be useful. And so really the takeaway message from this whole section is that informed decisions depend on accurate forecasts, which are unlocked by context. Okay. So the problem setting is motivating. We get it. Forecasting is a relevant problem. Context helps. But when we looked around, we didn't find much data or methods that actually do this, right? And so we think it's a severely underexplored problem setting, and that's a really nice opportunity because what's currently there is insufficient. And ultimately, our goal is to empower users with better decision-making abilities, and that requires models that can leverage context. And so that's why we decided to make the context is key benchmark, which is what I'll discuss in this section. Okay, so let's look at what the context is key benchmark is, which is CIK as abbreviated, or for short, we say KIC. And it's essentially a set of tasks that we can use to evaluate whether models can use context to improve their forecasts, right? So the inputs to the model that you see on the left here are context, right? Which is this relevant information, as well as a numerical history. And then what we're expecting is the model to use these two pieces of information over here to make a forecast like what we see over here. And the model is expected to output accurate forecasts using these information, which brings up a key point of the KIC benchmark, which is that tasks in KIC rely on the context, okay? All the tasks in KIC are designed such that accurate forecasts cannot be achieved without using this contextual information. And this is because we want to specifically evaluate the ability of models to leverage contextual information, which in this case is natural language. Okay, context is a pretty wide term, even if we're looking at natural language. It could mean a bunch of different things. There's tons of information out there that could be useful in various scenarios. So what we do is we identify different kinds of context in an effort to classify the different types of tasks and ensure that the benchmark is varied and covers most of its bases, right? So we categorize context depending on what kind of information they provide. And I won't go through every single type of context here. You can see that there are 5. I'm just going to go through this example that we have, which is our photovoltaic power plant, and say that in here we have 2 types of context, right? First, up here in green, we have this information that we call intemporal information, right? And this is information on the nature of the process. This is like, I tell you, it's a power plant. It's that information that provides information. And then we also have a second type, which is the history. And this is where I say that over the previous 90 days, the maximum power production happened at so-and-so date, okay? And so we're saying these are two different types of context. And so obviously tasks can have multiple types of context associated. So this is just an example to give you this idea of we identify different kinds of context. But to process the different kinds of context, the models need various capabilities, right? And so coming back to the same example, we have all these capabilities that we also identify in the benchmark. And for this one specifically, what we're looking at is the deductive reasoning capabilities of the model. So the model has to figure out this is a photovoltaic power plant, which gives it some information on what the prediction curve should look like, and also that the maximum power production happened on average at around 1120 on the previous 90 days. So it can use that to figure out that it's already close to the maximum. So in this case, we're evaluating deductive reasoning in that. Okay, so types of context, capabilities, makes sense. And overall for Kik, Kik is composed of 71 of these different types of tasks. And these 71 tasks range across 8 domains to ensure that our evaluation applies to many different settings. So we don't want it to work just for traffic. We don't want it to work just for energy, just for economics, things like that. We want to make sure that we can evaluate in many different domains. And so coming back to our example, obviously this is the power production of a power plant. So this falls within the energy domain. And that's the overview of Kik. Kik is the set of tasks. It deals with context sources, capabilities, and it's across a wide domain. So what we want, many domains. So what we want to do is use Kik to evaluate methods, right? And so now the final section is we want to look at current approaches and see how they perform on the Kik benchmark and see just how well they perform. Okay, so let's take a small tour of existing forecasting methods and how we broadly classify them, right? First, we have traditional statistical models, right? These are sort of the de facto methods. You can find them in the ServiceNow platform. Those are the ones that are generally used. And in this case, we're going to look at a specific method called exponential smoothing, which is a classic sort of forecasting method. Then we have foundation models, right? I'm assuming you know about large language models. Well, there are also similar models for time series. At least there's ongoing work on there. And one example of this is actually lag-llama, which also had its own AI Research presentation, and I recommend going to check that one out because it was pretty great. Finally, since we're interested in models that can process context, we're also going to look at large language models for forecasting, right? And since these models process text, they can handle context. And in this case, we'll look at Llama 405B, which is the largest Llama model of the recent release from Meta. Okay, so how exactly do we use a large language model for forecasting? Well, we have to prompt it, right? And so we're going to take a bit of a closer look here at exactly how we prompt this model. And it's actually quite simple. So we just instruct the model that we want it to forecast, right? So we actually give it the task. We tell it, I have a time series forecasting task for you, et cetera, et cetera. And then we just directly give it the time series and the context in this format over here. You can see in green, this is where the context goes. And then you have the history over here, and that's where the history goes. And just to highlight that this is like a very simple sort of de facto approach. And so there's a lot of possible work here. But let's look at the results on the Kik benchmark for these 3 methods, right? We have our exponential smoothing, our lag-llama, and our direct prompt method. And these are results on the Kik benchmark across all tasks for 5 instances per task specifically. What we use here is the ROI CRPS metric. I recommend checking out the full paper for details on that. But the point is, lower is better. That's what we want, right? So going from left to right, we have exponential smoothing over here. And we see that it's the worst out of all 4 models, right? Then we have lag-llama over here that reaches about half the value of exponential smoothing. And it's actually doing like much better, right? Then up here, we have the direct prompt where we avoid giving the context, right? And we see that better than exponential smoothing, worse than lag-llama. And then finally, what we see is that when we add the context to this direct prompt model, then we see that the performance drastically improves. It's better than lag-llama. It's better than exponential smoothing. And this is really what we want from the Kik benchmark, right? And so we really see that context is what is driving the improvement in performance here. And you can find more extensive evaluation results in the paper. Okay, so here's a small demo that I just wanted to show you. Where is the button to start the demo? Maybe I got to close the highlighter. There we go. Okay, perfect. So let's watch. This is within the ServiceNow platform. This was made by Alexandre Drouin, who is on the author list and a research scientist. And you can see here that I'm saying, imagine that the office is closed, and you see the model's prediction actually drops to 0, right? So the model gets it, the office is closed, there's not going to be any incidents open. Now, finally, I say, imagine that a new product is launched, and we see that the incidents opened per week. Well, what's going to happen? Okay, so the incidents are going to increase drastically given that a new product is launched, which is probably expected when we have a new product launch. And that's basically a demo of how this could be included within the ServiceNow platform. Okay, so moving on to areas of improvement, right? We've seen that large language models can do this, but there's a few flaws and a few things that we can work on. The first is that sometimes models misinterpret context and just go nuts, right? So here we have an example. This is a typical task, and we obviously, without the context here, we see that the model misses the target. But at least it's within range, but it has no context, so it can't know that, this value is going to be much lower over here than the rest of the series. No problem. Right. So now let's say we give the context to the model, which is helpful context supposed to help it forecast. And then what we see over here, if you can't see much on this plot, it's normal, because essentially what's happening is that 90% of the model's forecasts are way up here at a value of like 2000, whereas the ground truth is like way down here with values much closer to like 30 or something like that. And so actually what we're seeing is that forecasts are off by like 5,000%. And so the question is, what happened? Why did the model output this? And we don't know. It's a language model. It's a black box. And so one area of improvement here is definitely robustness of the forecasts. A second area of improvement is efficiency, right? How do we get efficient context-aware models, right? And this is actually probably a super important point, because over here we have these numerical models like exponential smoothing, and they're efficient, but they can't use context. Whereas language models over here can leverage context and so perform much, much better, as is indicated by lower on the y-axis, but they are slow, big, and expensive. And so what we really want is to go this way, right? We want better performance. We want it to be more efficient. And so, that's one direction of work, is figuring out how do we retain the context processing abilities of language models while improving efficiency. Okay, so that is the whole presentation. Here are some key takeaways from the presentation. First, forecasting depends on context. Okay, contextual information is relevant for forecasting. There are many tasks where statistical models perform well, but there are some where you really need context. Otherwise, you're missing information, and you're just not going to be able to do well on the problem. Right. Second is that we introduce the context is key, or KIC benchmark, for context-aided forecasting, specifically to evaluate whether models can do this. And finally, we have that LLMs can leverage context to improve their forecasts, but there's a lot of room for easy improvement. If you want, you can check out our website using the QR code here, which shows examples of tasks in the KIC benchmark. You can find the code on GitHub here, or you could check out the full technical paper on arXiv here. And thank you so much for your attention.